Hi, my name's Janet and this is an introduction into electromagnetic spectrum. Electromagnetic spectrum is a radiation energy which travels in waves and spans a large spectrum seen here. The larger the frequency, the lower the radio wave, as we can see here with the radio waves and here with the gamma waves. We'll start off with the lowest frequency, which is radio waves. Radio waves have the longest wavelength and the lowest frequency. Tuning into Radio 4 isolates a frequency band as a radio station broadcasts at that particular bandwidth. We'll take a look at different types of modulation. We have AM, which is amplitude modulation, which is a modulation technique used to transmit using various radio waves. The strength of the carrier wave depends on the message of that signal. Moving on to medium wave, where the frequency used is mainly for the carrier of broadcasting into approximately 120 channels. The qualities are limited, the signals are stronger at night usually than day, and we finish off with FM, which is frequency modulation, and this is the encoding within the carrier wave by varying frequency, using telecommunications, radio, broadcasting, signalling, and maybe computer signals as well. We move on to the next one. Oh no, this is explaining how the radio waves are carried through the ionosphere, transmitting through the molecules in the air. And here we describe how the radio works. By vibrations, or is a repeated process by vibrating electrical current in an antennae. And here we describe how the information is encoded and received through the radio waves. And we'll move on to microwaves. Microwaves have a higher frequency than radio waves. They range from 1 metre to 1 nanometre and have a long wavelength, which is ideal for cellular broadcasting. So if you use your mobile phone network, cellular is ideal. High levels of microwave radiation causes burns, as the radiation causes friction in water molecules with food or anything that contains water, which causes vibrations, resulting in the production of heat. Therefore, we get the burns. And here shows the stations where the microwaves are received, because they can only be received on straight lines, and these stations then divert that signal to another one of these, which then eventually diverts back to where it's received. We're moving on to infrared. Infrared has a lower frequency with a longer wavelength. We're talking 780 nanometers to 1 millimeter within the electromagnetic spectrum. Infrared can be identified as heat radiation energy. We cannot see, but we can feel it. Infrared is used in the military or rescue services for nighttime vision cameras or thermal imagery. To detect life forms, we use in remote controls, which sends a signal to our television, which is then encoded and received back and interpreted back into a message. We are aware too much infrared exposure can cause burns. Infrared from heat, a heat form, Moving on to the next one in the spectrum, which is visible light. We all know this one, don't we? Visible light is what the human eye responds to, these type of wavelengths, which would be between 380 and 750 nanometers. Visible light are wavelengths visible to the human eye. We use visible light to predict weather and can see other planets in other solar systems. Light bulbs, candles, clouds, TV, glow sticks, they're all a form of visible light. UV light, ultraviolet light. Ultraviolet light has the ability to penetrate our skin. Our skin produces melanin as a defense against UV light, which gives us that glow, hence the sunbed. UV light can all be used to kill bacteria or highlight bugs or scorpions as well. Just depends what light it is that it reflects from to give it the UV glow. It has to be that bright coloured, it can't be dark. We're moving on to the different types of UVA. Generally from the sun, UV is the strongest and UVC is the strongest and most dangerous ray with the shortest wavelength and cannot penetrate the Earth's surface. It is absorbed by the Earth's atmosphere. UVC destroys nucleic acids, disrupting DNA and bacteria, and UVA and B provide us with vitamin D. But overexposure pose a threat to skin cancers. And UVA has the longest wavelength, which causes aging of the skin. We're moving on to X-rays now. X-rays are at the other end of the spectrum. They have the shortest frequency. No, with the strongest frequency, but the shortest wavelength. They penetrate the skin, they reflect off the inner tissues of the body, which means that we can see bone tissue and layers of tissue to diagnose illnesses. Again, high levels are not good for us. Radiation in the body needs to be monitored because of the degeneration of cells, which can then mutate and cause cancers. And we finish off the presentation, we're talking about gamma rays. Gamma rays are used in cancer treatments. They penetrate the body, they isolate particular cells and kill them, but they also kill good cells as well. It is a form of cancer treatment. They're very penetrative and dangerous to expose if exposed to. They're at the top end of the frequency spectrum and the lowest wavelength, so they're the most powerful. Thank you for watching. It's been a pleasure. I hope you've learned a little bit more about electromagnetic spectrum. Goodbye.